So, quick review. We're learning about operations this week. How to maximize the quality of your operations. Oh, is it working? No, it's not. Okay. Try this again. Speaking of operations, you think I'd learn how to operate this thing by now? Okay. We talked about how all businesses have to take inputs, turn them into outputs, right? And operations is how you do that. How do you take those raw materials, labor, whatever they are, turn them into your products and services, and actually get them to your customers? We talked about how that involves planning for your future production, controlling your production as it's happening, and then evaluating to figure out how to improve it. That planning has both, short-term as well as medium and long-term implications, right? We talked about the difference between mass production and customization. And then the combination of mass customization, right? Where you can get products that are somewhat customized but at a reasonable cost because of automation. We looked at different industries and how they take inputs and turn them into outputs. And this was the last slide we got to. Here we looked at how you lay out your facilities to produce your products in the most efficient manner. So some companies might have a process layout. So you set up different processes in your facility so that, for example, when the materials come in, they might go to the foundry, to the rough machine, to, fabrication, painting, each of these different processes as is needed for that product. So that allows you to make different products by just routing them through whichever processes they need. And so that would make sense if you're making lots of different products. But if you're making one product over and over, then you just set up your facility specifically for that one product, right? So that it's efficient as possible. So it just goes chassis, circuit board, screen, speaker, final assembly, inspection. And you can just crank them out and make thousands of these flat screen TVs. On the other hand, in some cases, you have a fixed layout where you have to bring all the supplies and the workers to the product because it's too big. And you just make it in place. So that's what we had covered so far. We've got some interesting concepts to cover still on this chapter. Any questions or comments on anything before we move forward? Nope. All right. Well then, in your business plan assignments, which were quite good, by the way, I did get them all graded yesterday. If you did not get yours in yet, get it in as soon as possible, definitely by Saturday at the latest. But in your business plan assignments, you did think about what would be the location for your business. And why is that the right location? So I don't think we looked at this slide on Tuesday, right? Okay. So what is this location?
San Francisco.
You are right, San Francisco. It's got the famous Transamerica building. The insurance company Transamerica has been in that building for decades and decades. Anybody know this building here? That's the Salesforce building. Salesforce is one of the big tech companies. They make software for sales forces and for customer service management. So they are one of the largest tech firms. And this is over by where the piers are. A lot of tourists come down here. There are a lot of fun activities. I think Pier 39, I think the Exploratorium is over there, if I remember correctly. There's a fun arcade over there. A lot of fun stuff for tourists.
I plan to visit the arcade at Pier 39 one day.
Yeah, you should do it. I think you'd really enjoy it. Now, the reason I put this picture is to think about what kinds of businesses would do well in this environment. You've got, obviously, some skyscrapers here. You've got a big residential area. You've got the water area right here where the tourists go. What would be an example of a business that would make sense to put in a location like that?
Little hot dogs.
Little hot dog stand, exactly. With all those tourists going by, right? You could probably do really well. What would be a business that you would not want to put in this location? The car dealership. Yeah, you don't have the space. It's probably not zoned for that. There's a lot of traffic in this area, right? So it's not an ideal place. In fact, they usually put all the dealerships together in one area, right? Like over here, there's the Auto Center Drive or something, right? All the dealerships are there. So every organization has to think about that. We want to put our business where either we have access to customers, especially if it's a retail sort of business, or where we have access to suppliers and delivery vans and things like that. If we do a lot of logistics, shipping and receiving of products. If it's an industrial sort of business where we're actually manufacturing something, we want to be in an industrial area where you're allowed to have hazardous chemicals. Around here, you wouldn't want to have a lot of hazardous chemicals because of all the people that live by. There are tax questions. Sometimes cities will offer tax incentives to get businesses to come there. Access to employees, skilled people that can come work for your company. You want to be close to them. So there are a lot of considerations in deciding where to put a particular facility. Let's look at some of the technology and some of the approaches that are used to help manage organizations effectively and efficiently. First off, we have JIT, or just-in-time inventory management. Now, the idea here, if your business needs to get raw materials to make products, or maybe you're a grocery store, you need to get produce to sell to your customers, or maybe you're a retailer and you need products that you can put on the shelf. So whatever your business is, there's a good chance you have some sort of inventory. Well, how much inventory should you have? If you have too much, it's just sitting there collecting dust and costing you money. If you don't have enough, then you miss the opportunity to sell to some customers. So what companies used to do is they would hire extra inventory. They called it safety stock. So that, that if a delivery was delayed, it's okay, they had some extra and they wouldn't run out. But that gets expensive to always have extra inventory. Especially imagine a grocery store with 30,000 items, having extra inventory for all of that, very expensive. So over the last, 40 years or so, a lot of companies have started using this just-in-time approach to inventory, where you keep really just enough to meet your current needs and have your next batch of inventory arrive just in time. Saves you money. Even if you have to pay extra to get it shipped overnight or something, it still might be cheaper for you than keeping all that extra inventory. The problem is it's risky. What if that shipment doesn't come in, right? Then you might miss out on some sales. But overall, companies have found that it does save them money, especially with technology. Some companies today, like Walmart, for example, they have really close connections to their suppliers. So if Walmart buys products from Johnson & Johnson, for example, their systems are connected so that Johnson & Johnson knows when Walmart needs more product, and they can just automatically send it. So that use of technology helps keep just the right amount of inventory coming in at all the time. Any questions on that? Okay, then we have MRP, Material Requirements Planning. If you've ever worked in a manufacturing facility, you might have used an MRP software system. It is used to help schedule and plan production. So those are very common in manufacturing. Then we have ERP system. These can be used for any type of company, but usually only large companies can afford an ERP system. As it says here, it stands for Enterprise Resource Planning. This is used to plan for the entire organization, the entire enterprise. And you can plan not only materials, but also your cash flow. You can plan how much labor you need, because an ERP system actually is represented here in this diagram. It's like one huge software program and database for the entire company. You know how if you want to see your assignment, you log into Canvas. If you want to register for a class, you log into Pause, right? And sometimes it's a hassle to have all these different things you have to access that don't communicate with each other. So imagine one day in the future, I don't know when, hopefully in my lifetime, our community college system here in California will have some sort of ERP system where you just log into one thing and you can access everything you need. So that, for example, I as a professor don't have to look at your final grade in Canvas and manually enter it in Pause, which is what we have to do, right? Which means we have to be really careful that we put the right grade in Pause, which I have a really good track record of doing that, but I'm not perfect. So if you think I gave you the wrong grade, let me know. But wouldn't that make sense, right? Get those systems to work together. So when companies have enough money and the time, because it takes probably a year or two to implement one of these ERP systems, they can put in this program that every department in the organization uses, so everybody's connected to the same central database. So that's what an ERP system is. Some of the common ones that are out there are Oracle, SAP is another big one. So if you hear those names, those are ERP systems. And then RFID is an interesting technology. Anybody familiar with radio frequency identification? So this allows little computer chips to communicate with the computer wirelessly. So imagine that you're Walmart. I don't know if they've accomplished this, but I know at one point this is what they were planning to do at Walmart. They wanted every product sold at Walmart to have one of these RFID chips, either in the product or in the packaging, so that they always know where all of their inventory is. The computer system communicates with every single product wirelessly using radio waves. And so you don't have to go through and count all your inventory or try to see if somebody stole it. You know where it is all the time through the radio waves. So that's something I know Walmart was working on. Whether or not they've actually implemented that, I don't know. But that technology, it's been around for a long time, but of course, there's a cost to it as well. I've heard the military uses that too to keep track of some of their inventory. So, questions or comments so far? For those who came in the last like 10 minutes or so, we already did the grow activity. So you can talk to your group members maybe after class and see what you missed. But I switched up the order of things today. All right, sometime in your career, whatever field you go into, you might find you have an opportunity to be a project manager. That's become common in all kinds of different industries. And I think the reason is the world is changing so quickly with new technology, new laws, things are just rapidly changing. And companies have to always be adapting to these changes. So they're always coming up with projects. And then they need people to be in charge of those projects. So whatever your career path might be, at some point, your boss might come to you, or there might be an opening in the company for you to be a project manager. And if you're good with organizing, if you're good with interacting with people, because a lot of it has to do with communication, it could be not only a very interesting and challenging experience, it could be a whole career path where you just end up being a project manager through your career. And we're going to look at 4 different tools that project managers use. I'm just going to cover maybe 2 of them right now, and then we'll take a little break, and then we'll look at the others later. So one tool you could use as a project manager, and by the way, you could use this in your own life. You could use this for planning out your college experience. You could use it for planning out a job search, any kind of project you're working on, you could use these same tools. So a Gantt chart is one of those tools. If you use this program, Microsoft Project, you can use it to make a Gantt chart like this. I'm sure there are other programs out there for doing this, but Microsoft Project is the one I'm most familiar with. So in this example here, this Gantt chart, this company is developing and selling a product. So they've listed out what are the different activities. They need to schedule it all, they need to design it, order, get the materials, et cetera, and eventually ship out the finished product. Okay, so those are the different steps. And then they've got a timeline starting with September 14th and then going, looks like, till the end of October. So this is a very simple process. What you do is these, I guess they kind of look like staples, don't they? These lines here, those indicate when that activity could start. So this is the earliest we could start it, and this would be the latest it can end for us to stay on schedule. And then the black rectangle is the actual activity, what actually happened. So you see that for scheduling, it started, a day or 2 after it could have started, but it actually finished a little bit early, which is good, right? Usually better to be ahead of schedule instead of behind schedule. And because it finished early, they were able to start the next activity early, designing. Unfortunately, for some reason, the designing process ended late. There was some delay. Then you can see that caused ordering to also be delayed, and that ended up late. Delivering materials started kind of late, but it looks like that's finished. This is where we are right now, October 8th. But here's the question. See how with this machining components activity, there's this big X, and it says that the machine's not going to be available because it'll be under maintenance. Now we've got a little bit of an issue, right? Because we're starting machining a little bit late. Are we going to be able to finish it by the deadline? And then we don't know yet, right, what's going to happen after that. So this is how you can use it to schedule out your activities, monitor and keep track as time goes on. And then after the fact, look back and say, for example, why did designing take us so long? And why did we have to do the machine maintenance right in the middle of this, project, right? So it could be used for planning, controlling, and evaluating. That's how you might use a Gantt chart. Any questions, any comments? Nope. All right, let's look at one more, the critical path method. So this allows a little bit more complexity. In this case, it's building a house. And we start at the beginning here. Did I start recording earlier?
Yeah, you did.
I believe you. I don't believe myself necessarily. Let's just double check. You are right. I did. And I remember it now. Okay, good. All right. Like I said, did I say it? I was up late reading papers last night. So. All right. So imagine we're building a house. There's a lot that goes into building a house, right? And you want to finish on time and hopefully within budget. And at least for the time component, you might plan it out like this. So starting here, we're saying the first step is to lay the foundation. And we expect that to take 5 days, right? You need the foundation first and then you build above that. So the next step is to put up the frame of the house. That would take 7 days. But then look at what happens after that. Once the frame is up, we could start putting in the plumbing, the wiring, the cabinets and walls, and the siding. All of those activities could start happening at the same time. And the estimate of how long they're going to take is different for every item. So the thing that's going to take the longest is this 15 days to put up the cabinets and walls. So that is the critical path. That's why this is called the critical path method. If the siding gets delayed, it's okay, because that only was going to take 3 days. And it's going to take 15 days to get the cabinets up, right? And they're happening at the same time. So if this gets delayed, it's no problem. If the plumbing or the wiring get delayed, again, not really a problem. But if this critical path gets delayed, then the whole project is going to be late. Because that's the thing that takes the longest. And then you can just follow that critical path. This kind of salmon color here is the critical path and gets us to the end. So this, it's a little more complex than the Gantt chart, which really only shows one activity at a time. This can show multiple activities happening simultaneously. Right, questions or comments? Okay, so let's go ahead and pause here. Now, a big part of operations is continually improving your organization, which we will be talking about some more. We had just learned about the critical path method. So here's something called the PERT method. And this is similar to critical path, but it allows for a little bit more complexity. So this might be useful in managing your project. So again, we see the different steps in the project. So we've got steps A, B, C, D, E, F, and G. And then we do see a critical path again, the salmon color that they use to show what's the critical path, right? So those are the tasks where if they get delayed, the whole project gets behind. But you notice all these numbers here, right? So let me see if I can get it right, because yesterday, I didn't explain it very well. So let me try to make sure I get it right today. I know, exactly. So the number in the upper left is the earliest start date for that task. So obviously, if you're starting a project, whatever time you start, that's the beginning, right? So that would be day 0. And this project is estimated to take 2 days. So that means that it could start as early as, it could end as early as day 2, right? And let me check that, make sure I'm not, make sure I'm not off on a wrong track already, because I have the notes here. Yes, the earliest it can finish. Good. No flag. Okay, so we have the earliest start, how long it's expected to take, and the earliest finish. This would be the latest it could start. In this case, it's also 0, which means that there's no slack. The middle number on the bottom is how much slack you have. So if that first task gets delayed, the whole project gets delayed. So anything that's on the critical path, you see that there is 0 slack. And this would be the latest it would be able to end, to stay on track. So notice here, because this is not part of the critical path, you actually have some slack, 4 days of slack. So it can start as early as day 2, or it could start as late as day 6. So this gives you more detail, right? And if you're actually managing a project, this would be useful. Once you get familiar and used to how to use this, you see how it might be helpful to make sure your project is staying on track. So again, that is called PERT, which stands for Production Evaluation and Review Technique. Any questions or comments? Then we go to value stream mapping. I'll zoom in on this one. Now, what's different here is you include the entire supply chain in this process. So you're not only planning your organization's activities, you're including anything that adds value to the whole production and delivery process. So everything, including your suppliers, getting you the supplies, receiving them, all the different processes in your organization, getting them shipped out through your delivery company, and reaching the customer, and then even getting information back from the customer to make a new forecast. So it looks at the value that's added through the entire supply chain process, maps it all out to keep it on track. Again, this is called value stream mapping. And then notice there's this word here, Kaizen. Anybody familiar with that Japanese word? Anybody know what Kaizen means? So it's actually used fairly commonly in the business world. It basically means continuous improvement. So it's this idea of always trying to make your organization better. And Japanese companies can be very, very good at this. And we'll talk about that in just a moment. This gentleman here, W. Edwards Deming, is considered, well, he's not with us anymore, but he was really looked at as a guru, a great business mind that had a major impact on how organizations do things. He, I'll just give you a little bit of his background. Deming was a statistician. That was his job, statistics. And he worked for different government organizations, eventually went, I believe he did some work at AT&T's Bell Labs, but he became a very well-regarded consultant. Companies would bring him in to look at their processes, and he would apply statistical techniques to figure out how they could improve their processes and teach them how to do that as well. Well, from what you know about history, you know that World War II did not end very well for Japan and for Germany, right? Their economies were pretty much decimated, and they obviously lost the war. And it was in the interest of the United States and other advanced countries that we help those economies to rebuild. In fact, I've heard it argued that that was a mistake after World War I. Germany was in such a bad economic state after World War I that led to the rise of Hitler and Nazism. So we didn't want to repeat that mistake. We wanted to help them rebuild their economies so that they could be partners. And if you think about Germany and Japan, they are allies and economic partners of the United States today. So why am I telling you this? Well, Deming and some of his other contemporaries went over to Japan to help them figure out how to rebuild their economy. And he brought some of his statistical techniques and his philosophy that is typically referred to as total quality management. Total quality management. How do you manage the quality of your organization so that you create products and services that are high quality but low cost? How do you do that? You have to continually improve your processes. And that's what he was really good at. So he worked with Japanese companies, and this would be, we think about Toyota, Honda, Sony, Mitsubishi, these companies embrace his philosophy. And it worked really well for them. Because in Japanese culture, it's normal to work in groups and try to solve problems together. That was something that their culture was very comfortable with. And it was normal to plan for the long term and think about, how are we going to make this organization better, not only now, but in 5 years, in 10 years? How can we do things today that are going to help us in the long run? And so what we saw within just a couple of decades, you had all these Japanese firms being really successful. For example, the big three automakers at the time were Ford, GM, and Chrysler. And American cars were, being exported all over the world. Everybody loved these American cars. But then along come these Japanese imports into America. And people are saying, you know what? These imports from Japan are actually better quality than the American cars, and they're cheaper. How do you do that? How do you make a product that is both better and cheaper? That gives you a very strong competitive advantage. Well, how they did it had a lot to do with Deming's total quality management philosophy. Always improving your processes to get more efficient and more effective. Now, American companies, car companies and other companies as well, decided, hey, we're going to do this TQM, total quality management thing. So they tried to implement these principles and these statistics and these teams that work together, and it didn't work. They're like, what's going on? It's working in Japan. Why isn't it working here? Well, if you look at American culture, we're not very group oriented. We tend to be very individualistic. And if you look at our time horizon, we want things now. We don't want to do work today that's going to give us benefits in 5 or 10 years. We want results today. So it took a cultural shift, and it, probably wasn't for maybe 10 or 20 years before American companies really started to get the hang of TQM, total quality management. And now I think if you buy an American car, they are comparable to Japanese cars in quality. But it took us a while to get there. And it's not just in manufacturing. These principles can be applied to other industries as well. So we can thank Deming for a lot of that. Oh, and then this is something that's often used in manufacturing, the Deming circle. He himself, being a humble person, admitted he did not come up with this. He credits his mentor for developing it, but still people call it the Deming circle. It's a very simple idea. You plan whatever you're going to do, then you do it, you check the results, you figure out how to improve it, and then the cycle repeats. So again, this is in that spirit of continuous improvement, or Kaizen, so that you manage the quality of your organization. Now, there are different branches of TQM that have evolved, different approaches to it. One is called Lean, and actually that one came from Toyota. Toyota developed a way to get waste out of their processes so they could save time, save money, save energy. And again, it's through groups, teams working together to say, why do we do things this way? How can we get rid of some of this waste? For example, let's say you've got a worker that works at this workstation right here, and their tools are way over there. They're spending a lot of time just going back and forth. Why don't you move the tools to where the worker is, right? It's that kind of thing. And doing that makes you more efficient, makes your organization more lean. So that's one, whole approach to TQM. Another one is called Six Sigma. Anybody heard of that before, Six Sigma? How many people have taken a statistics class? Oh, quite a few. Okay. So you might have heard the term Sigma. right? It's how much variation is in your process. For example, let's say we took the heights of everybody in this room. The heights would vary, right? We'd have, an average height based on everybody's heights. We could mathematically find the average. There would be somebody that would be at the low end, somebody that would be at the high end. And sigma is how much variation there is in those numbers. Ideally, in your manufacturing process, you don't want a lot of variation. You want your products that you're producing to all come out the same, if you're mass producing, right? You want each can of Coke, each sneaker, to be identical to the one before it. Otherwise, you might have to throw it away, and that would be wasteful. So just to keep it simple, companies that achieve Six Sigma in their techniques, out of 1 million units that they produce of their product, only 3.4 would be defective. That's about as close to perfect as you could get in manufacturing a product. So that is a whole approach to total quality management called Six Sigma. The cool thing about it too, if you get certified in Six Sigma, they've got a green belt certification and a black belt certification, kind of like martial arts. I don't know why they picked those names. There's also another approach to quality management that comes from Europe. It's called ISO. If you sell your products to Europe, to companies in Europe, you have to meet ISO regulations, or they can't buy your product. So a lot of American manufacturers are familiar. ISO 9000 is the current set of standards for production of products. They also have ISO 14000 that is a set of standards related to environmental sustainability of your products. All right, so these are all aspects of quality management. Any questions, any comments? All right, I think this is the last slide before our matching activity. Okay, doing a time check. Now, when this textbook was published, which I think was 2017, somewhere around there, they mentioned the anticipated worker shortage. The anticipated worker shortage. I think what they were thinking about was people born between the end of World War II, 1946, and then about like early 1960s. Those are the baby boomers, right? Because there was a big boom in births after World War II. And that group of people was reaching retirement age. So a lot of those people have retired. And the thought was that's going to lead to a big shortage of workers. Well, we do have a worker shortage, and it might be partially due to that, but I think there are a lot of people in their 70s, late 60s and 70s that decided not to retire. They're still working. So the worker shortage we have probably has more to do with just how quickly the economy has been growing, the recovery from COVID, other factors. What does the future look like, though? Are we going to continue to have a worker shortage? Maybe, but maybe with AI and automation, we might have a surplus of workers, right? That's a possibility as well. Either way, it has an impact on businesses. If it's easy for them to find the workers they need, they don't have to pay very much. They can keep their wages low. If they're having a hard time finding workers with the skills they need, then they have to raise pay. And in that case, then they're more likely to switch to robots and automation because it'll save them more money, right? So it's hard to really predict how that's all going to go. One last concept we'll address in this chapter, business process management. That's a whole field that has evolved. where there's some companies that specialize in helping other organizations improve their business process. So if you're trying to figure out how to save money on your production or just make a better quality product, you might bring in some consultants or specialists that can analyze your business processes, help you improve them. So we've reached the end of chapter 10. We're up to our final matching activity here. We've got about
10 minutes left.
about 10 minutes left. Thank you. Yeah. Thank you, Eric. I don't know what I'm going to do without you next semester. Are you going to be in my financial accounting class?
I don't know.
No, you don't know. We'll see. All right. Well, I'll have to manage one way or the other if you're not there. So here we have 8 learning objectives. Let me just zoom in so you can see some of these a little better. I know some of them are kind of small. Oops, not do that. All right. We have one graphic over here. Another one in the top right here. We've got this one with the 9 squares going on. And the rest of them are I think, a little bit easier to see. All right, so give it a minute to see what matches you can make there, and we'll go through it together. Starting with operations management. Which image matches that?
Number 1 would be this one.
Okay. No, what were you gonna say? Okay, the one that says operations management. Okay. You can see all the different aspects of operations management we've discussed there. How about different production processes? Was that?
So the one all that's the start and then it goes from 3 different
This one?
ways.
Okay.
Yes.
Yeah, so that one, it's actually the process for building a teddy bear. And it's got a critical path here, which is the teddy bear itself. But then you've got making accessories, because of course your teddy bear has to have accessories, right? And then making clothes, because you wouldn't want your teddy bear to not have clothes. So yeah, that could be a process you use for production. How about designing your facility? What's a good match?
The top,
Which one you want?
the design is the mass production with customers.
Okay, yeah, so you would design your facility differently if you're mass producing than if you're customizing products, right? Now, this chart is kind of interesting because what it shows, if you're mass producing,
With customers.
you can keep your price low, but your customization is also low,
Yeah.
right? Because it's just the same product over and over. On the other hand, if you're customizing your products, the price is going to be high and the level of customization will be high. But mass customization allows you to keep your price low and your customization high, right? And that's where you use technology to help you customize products that otherwise would be mass produced. But notice, you wouldn't want to be in this corner, having low customization and a high price. Who's going to pay for that, right? Who's going to pay a high price for something like a can of Coke? You would not do that. You expect it to be relatively cheap. Okay, next would be inventory management.
I would say the one of the warehouse.
Okay.
where
Yeah.
Every box stacked up neatly.
Exactly. We see inventory up on the shelf. We also see some inventory, if you can see it, on the floor on these pallets, right? And those pallets are good for these forklifts to come up and just lift it and move it into place. So it looks like the ones that are on the floor probably either just got delivered or maybe they're in the process of being shipped out. What else do we have? Scheduling and controlling production. Good option there. Yes. Okay. Yeah, so here we see a layout where we've got 3 workers that can work independently, right? They've got enough room to do their own thing, but they can also work as a team. So that might be very useful in controlling your production. Then we get to quality management. No? Okay, yeah, exactly. This is Six Sigma. As I mentioned, you could use statistics to evaluate your processes. And if you achieve Six Sigma, then it's only 3.4 defects per million, as I mentioned earlier. And this shows, looking at a process, this would be your average results. This would be the high end. This would be the low end. And each of these lines here is 1 standard deviation. So if you can keep it so that your production is within 6 standard deviations, that means almost every product is coming out exactly right. So when you take statistics, you can learn more about how that works. Then we've got technology and automation.
This
Takers,
one.
which one?
This one?
This
Yeah,
one
this
here.
one, yeah, or this one. I don't know if this one, the one, and the yellow one is like a machine or something, I don't know.
Could, yeah, it looks like probably like some sort of conveyor belt. So there could be some technology and automation there.
Mhm.
And with this one, obviously, the guy's on his laptop with his child on his knee. So he might be controlling a factory or hacking into a factory. We don't know.
It's like a working in the
But
company,
he's
they
using
take it, this is a
technology.
person,
It's like a
this is a rollover, you know.
Yeah.
The only image we have not used is this one with the 9 squares. Let's take a look at that so you can see what it is. This shows the evolution of printing from before paper, where you had to sort of record things in metal or stone,
Mm.
until the printing press, where you could actually print things out on paper, right? To computerized printing, color printing, and today even 3D printing. So obviously technology's advanced, and the rate of technological advancement is hard to keep up with. It's amazing how much, like the video we saw the other day, right? How many inventions there are.
No, no,
Final thoughts as we wrap up our semester here. Any questions, comments?
It's a great course.
Oh, thank you, I appreciate that. All right, if there's anything you need to talk about, I'll stick around. Otherwise, have a great summer, everybody.
You're the best.
Hopefully I'll see you in financial accounting.
Wish you the best.
Okay, Daniel. No crutches, huh?
No questions.
All right, nice. That's improvement.
And then you said you're gonna be doing a class for the summer?